Okay, let's take a look at a couple of examples of factoring differences of squares. Okay, now what do I mean by difference of squares? Well, exactly that. Something that is the square of one thing, and then you're subtracting the square of another. Okay, and it's not completely obvious how to factor this if this is all you have seen. However, going the other direction, we often will multiply some sum of two terms by the difference of those same terms. And if you expand this out, look what's going to happen. You're going to get an x times an x, that's x squared. You're going to get a y times a negative y, there's a minus y squared. But then in terms of your inner product, plus yx, and your outer product, minus yx, those two things cancel each other out. So you're only left with this difference of two perfect squares. Okay, so this actually is a tremendous tool for factoring, right? So whenever we see a difference and the first thing is a square of something, the second thing is a square of something, we can now write it in this form as a product, right? And where the first thing is the sum of whatever you squared to get this guy and whatever you squared to get this guy. And likewise for those two terms. Okay, so let's look at a couple examples. Number one, 9x squared minus y to the fourth. Okay, so first off, to even tell that you can do this, look, you've got a binomial. Okay, it's two things. They're subtracted, so it's a difference. The question now is it a difference of squares? Is there something nice that you can square to get this term? Well, sure, 3x would work, right? Is there something you can square to get this term? Sure, y squared. That makes it a difference of squares. We can immediately then go to, this is the product of the sum of those two things times the difference of those two things. And we're done, right? Difference of squares problems are typically very fast, very quick application of this. All right, let's look at another example. Number 2, x to the fourth minus 16. Okay, can we treat this like a difference of squares with regard to factoring? Well, clearly it's a difference. We have a negative there. Is this the square of something? Sure. X squared squared gives x to the fourth. Is this the square of something? Sure. 4 squared is 16. So I can immediately say, hey, this is a difference of squares. I can write this as the product of the sum of x squared and 4 and the difference of x squared and 4. All right, so we have a factorization of this. But hold on. Don't get too excited yet. Are these things completely factored? Look right here. That is also a difference. And that's a square, namely of x, and that's a square, namely of 2. This can be broken down further by the same trick. Okay? This one unfortunately cannot. Right? We have a sum of squares here that doesn't factor nicely most of the time. All right? So we can, however, do, let's bring this along for the ride, x squared plus 4. We can, however, do is write this as the product of x plus 2 and x minus 2. Okay? That is a complete factorization of x to the fourth minus 16 that use difference of squares twice. Okay? That's it.